let's think about graphing. Oh, it's great. You get to see what's going on. So f of x is equal to log base 3 of x minus 1. Now, we don't have the log button or the ln button on our calculator that is base 3. I know a few of you are going, yeah, but my calculator will let me do something else. Or I remember something else from last year. Technically, we don't know those things right now, so we can't use it.
I have it in there actually.
You know what it does?
No.
Okay, well then we can't use it if you don't know what it does.
We can figure it out. I don't agree with that.
Well, I want to show you something else anyway. I'm going to use a different technique. So what we want to do is we want to actually find the inverse of that function. And the reason we do that is the inverse is supposed to be what kind of function? Well, this is supposed to be 1-to-1. The inverse is supposed to be 1-to-1. But what basic function is something we have been dealing with, we do know something about, that is the inverse of a log function. It is the exponential functions. We can graph exponential functions. We can learn about exponential functions. And then because of all the information that we remember from our days of inverses, we know that what is the domain here becomes the range over here in the inverse. And what is the range here becomes the domain over here in this function. And so if we find out details about a function we really can graph, then we should be able to find some points and look at the graph to find this function over here. So let's go back and recall, how is it that we go from one function to the inverse of that one function? What do we do mathematically? How about you say that louder?
Replace y with x and x with y.
Oh, before we get to that step, what's one thing we want to do first?
Yeah, that.
Yeah, that. What's that thing that you're talking about? Instead of writing it as f of x, and replace that with y, so it's y equals now instead of f of x equals. And then you said we can do what?
Replace y with x.
So because it reflects across the line y equals x, we can trade out x and y. Like that? Would you agree? All right. Now what? You guys were so good at this a couple of chapters ago. What happened? Is it 2 chapters? Is that what happened? What else did we do, guys? Solve for y, correct? So if I'm in this statement right here, by definition, what can I write? Base 3 to the power x is equal to this quantity over here. Is that the correct use of the definition of a logarithm? Now what? Yeah, I'm going to add 1 to both sides. So y is equal to 3 to the x power minus 1. Now I'm going to write that in parentheses to emphasize to you that that minus 1 is not part of the exponent. I don't want you to be confused by that. Yes, sir? Yes, thank you. That's what I want. Appreciate it. But I want to make sure that that 1 is not part of that exponent. Okay, so what does this mean? Could you, I think I can you graph 3 to the x power plus 1?
Yes.
Okay, let's do that. Since apparently you can.
So we're not allowed to just plug it into our calculator the other way on test?
That's not what I said. I'm hoping we learn more between now and our test that will give you additional tools to let that happen. We just don't know how those tools now. So when I plug into my exponential function x being 0, I get a y number of 2. Is that correct? Okay. When I plug into this inverse function x being 1, I get y to be 4. And when I plug into this exponential function x being negative 1, I get y being 4/3. Is that correct? Do you agree with that? Do you understand how I got all those numbers? Not taking silence is a good thing right now. All I did here is I plugged each of these x numbers into this exponential function for x and evaluated. And so when I have 0, 3 to the 0 power is 1 plus 1, that gave me y being 2. Then when I put 1 into here, 3 to the first is just 3, then plus 1 more, that gave me 4 for the y number. And when I plug in negative 1 here, I get 3 to the negative 1, which is 1/3 plus 1 whole. So 1/3 plus 3/3 gave me the 4/3.
What's the dash line?
That's a horizontal asymptote line. Actually, it really only needs to exist in the negative direction because it's asymptotic on this side over here, and then it begins to curl up. And so the function itself looks something like this. Questions about that? Okay. Now, please remember, the original f of x is log base 3 of x minus 1. So it should tell me some things. From translations and transformations of functions, I know that when I have this right in here, I'm sliding everything to the right one spot as a transformation. But I'm also looking at this and I'm realizing there's a bit of an asymptotic line right here. That's going to then reflect across the line y equals x, and it's actually going to become a vertical line right there at x equals 1 that is an asymptote as we go towards negative infinity. As I consider this ordered pair right here, in the original, the inverse causes the x's and y's to trade, and so it is actually at 4/3, comma negative 1 is a point that's on the log function. And then when I'm looking at this point right here of 0, comma 2 on the original, I trade x's and y's, it becomes 2, comma 0 as a point on the logarithm function. And then I look here at 1 and 4 on the original, I trade, and that becomes 4 and 1 on the logarithm function. And so I have this graph that goes here. There's the log. There's your f of x that we're looking to graph. And yes, I'm aware, that's a lot of work. But I'm also thinking you're going to start figuring out how these relate to each other and how inverses relate to each other, and that will be a benefit to you as well. Questions about this? Okay. No, you don't have to graph very many today. But I will tell you, a mistake that I see from students, a mistake that shows up on your calculator, is this does extend down that way and it keeps going. It heads towards negative infinity. You need to note that, and that's an area where I see mistakes, and I'll probably be looking for that to happen when you graph them on your paper, on a quiz, or on a test. So Please be aware of what it actually does and drop it appropriately. So make that as a note if you need to. Questions about this? Okay, we've already looked at several things. We've looked at the definition, we've looked at properties, we've looked at simplifying some things. We actually solved the little equation. We looked at the graphs. So what does that leave me with? Applications!